Conservation of linear momentum. The law of conservation of linear momentum says that the total linear momentum of an isolated system before a collision is the same as the total linear momentum of the system after the collision. Let's look at some of these terms. First, what is a system? When we're dealing with collisions, a system includes all objects involved in the collision. What is an isolated system? In an isolated system, the vector sum of the average external forces acting on the system is equal to 0. What is an external force? External forces are forces that are exerted on objects in the system from agents that are outside of the system. In contrast, internal forces are forces that the objects in the system exert on each other. So the law of conservation of linear momentum applies only to isolated systems. Let's examine a couple of systems. Let's say first that we have two air pucks moving toward each other on an air hockey table so that they will collide. Let's say that friction and air resistance are reduced so much that we can ignore them. The only other external forces acting on the pucks are the force of gravity and the normal force from the table. These two balance each other out because the pucks don't have any upward or downward acceleration. So, since the sum of the average external forces is equal to 0 in this case, this is an isolated system, and the total linear momentum of the system before the two pucks collide should be equal to the total linear momentum of the system after the two pucks collide. What about a system where a ball is being thrown straight upwards? We know that the ball will go up and then fall back down due to the external gravitational force acting on the ball. The ball will collide with the ground. Even if we ignore air resistance in this case, we cannot ignore the gravitational force that is acting on the ball. So the sum of the average external forces is not equal to 0 in this case, which means it is not an isolated system, and the law of conservation of linear momentum cannot be applied to this system. Let's return to our air hockey table. How do we apply the law of conservation of linear momentum to a system? The first step is to identify the objects included in the system. Remember, these are the objects involved in the collision. In this case, we have the two air pucks. We call the blue puck object 1 and the red one object 2. Next, we need to identify the internal and external forces. We said we could ignore the external frictional force and air resistance, but we do have the external forces of the gravitational force and the normal force from the table acting on the pucks. Internally, during the collision, each puck will exert a contact force on the other puck. Next, we need to determine if the system is isolated. Remember, the system is isolated if the sum of the average external forces is equal to 0. We determined that the gravitational force and the normal force on the pucks cancel each other out, giving us a net average external force equal to 0. So this system is isolated and we can proceed. Next, we set the total initial linear momentum of the system equal to the total final linear momentum of the system. Total momentum is given by capital P. So P initial is the total linear momentum before the collision, and P final is the total linear momentum after the collision. The total initial linear momentum of the system is equal to the sum of the initial linear momenta of each object. In this case, it's equal to the linear momentum of puck 1 plus the linear momentum of puck 2. This is the same for the total final linear momentum of the system, so we can rewrite our expression this way. Remember that the linear momentum of an object is its mass times its velocity. Substituting that in, we get this expanded expression for the conservation of linear momentum of a two-body system. In this expression, m1 is the mass of puck 1, and m2 is the mass of puck 2. v1 initial is the velocity of puck 1 before the collision, and v2 initial is the velocity of puck 2 before the collision. v1 final is the velocity of puck 1 after the collision, and v2 final is the velocity of puck 2 after the collision. You will use this expression over and over when you're dealing with collisions and conservation of linear momentum. Just remember to make sure that a system is isolated before applying the law of conservation of linear momentum.